Okay, so it's day 20, and let us see how this one goes. Hopefully it's not too bad. It will be. Finally, time to back up the L's. When you try and contact them, you get no reply. Perhaps you're out of range. You know the head of the grove where the starfruit grows, so if you can figure out where that is, you'll be able to meet back up with them. Fortunately, a file contains grove coordinates. It's encrypted, decrypted, mixing the encrypted file to mix file. Move each number forward or backward in the file. Number of positions equal to the value of the number being moved. The list is circular, so moving a number off one end of the list wraps around to the other end as if the ends were connected. For example, to move the 1 in a sequence like this, the 1 moves 1 position forward. To move the -2 goes that. Numbers should be moved in the order they originally appear in the encrypted file. Numbers moving around during the mixing process do not change the order in which the numbers are moved. Consider this encrypted file. Mixing this file proceeds as follows. Initial arrangement. 1 moves between 2 and -3. 2 moves between -3 and 3. -3 moves between 2 and 0. Thousandths, 3,000ths number. Mix your encrypted file exactly once. Okay, so let's see, are there duplicates? Because we'll need to deal with it slightly differently if there are. Well, let's try it. With open day20.text as f raw equals f.read, and let's say numbers, what do we want to call it? Yeah, numbers equals int x for x in raw.split lines. Okay, so let's run this. $5,000, then set numbers. Okay, so there are duplicates. So that's good to know. So now let's think about how to do this. File is a list of numbers. Okay, so data classes, import data class, class, encrypted file, numbers, which is going to be a list of int. And then let's just say order, which is going to be deck of int. No, I don't want to do that either. So let me read the instructions one more time. So the sequence 1 moves 1 position forward, 2 moves 2 positions backwards, wrapping around. Right, okay. Let me just do order, which is a list of int. So what I was trying to optimize is it's very inefficient to slice length equals it's very inefficient to slice lists and do it around. But if we're not doing it that many times, then I don't care that much, to be honest. So def post in itself, self dot n equals len numbers, and self dot order equals list range n. Okay, so that's what I want to do. Let's just say I equals 0, index of next move, Okay, so let's say def step self, and let's say n equals self dot numbers I. And let me think about how to do this without screwing it up. It'll be easier if I do this, and int equals 0, and I int equals 0, self dot n equals strange self dot n. Okay. So now I want to step self. So find m equals self dot numbers I. Okay. Find the ith original number. Okay. And now some of these are really big, right? So to move equals m mod self dot n, right? So basically every time I move by the length of the list, numbers self dot I, and then finally at the end self dot I equals self dot I plus 1 mod self dot n. Okay, so number of places to move. If and current location equals self dot order of self dot I. Okay. And so now a couple cases. If current location plus to move is less than self dot n, okay, new location and then self dot order equals self dot order. We're gonna have to concatenate a few things. Self dot order up to self up to current. No. See, this is why this is confusing. And order 3 equals 7 means that numbers 3 is in location 7. No, I should have it the other way around, right? It means that numbers 7 is in location 3. don't want to call that number that. Well, order 3 equals 7 means that number 7 is in location 3. Yes, new location equals current self dot order equals everything before me plus everything after me plus okay, I don't like this approach at all. One moves one position forward. So I slice that. So 1 is in position 3. Now I want him in position 4. Okay. Let me try a completely different n, which is an int. Next node or none equals none. Prev. No. Okay. And so let me yep, I think that's what I want. Okay. So we'll see. This might be too slow, but and I, which is an int, equals 0. Def step self. And let's say n equals 0. N equals len self dot numbers. This might be too slow, but this is a more sensible way to do it. Node equals self dot nodes. So I. To move equals self dot numbers. To move equals node dot n mod self dot. This is going to screw me up because I have too many n's, but that's fine. And I think mods are always going to be positive, right? -3 mod 8 is 5, yes. So for blank in range to move, let's just say node.prev.next equals node.next. And then let's say next node equals node.next. Okay, and so hook previous to next. And attach me after next. Node.next equals next node.next, and node.next.prev equals node. Okay. Okay, so previous next hooks up to the guy after me, and the guy after me hooks back up to me. And now I need to go node. I feel like I've missed one. And let's say, let me change this. Before equals node dot after equals node dot next, and after equals after dot next. Okay, so hook up before to after. Before dot next equals after dot prev equals before. Hook up after to node. After dot next equals node. Node dot prev equals after, and then hook up node to after. Next equals after. Okay, that should be good. I'm worried this will be too slow, but we'll try it. So now mix. To mix the file, the list is circular. So probably in part 2, it's going to ask me to mix multiple times. So def mix self for blank in range self.n self.step. And then we need to find a 0. so now one more, which is grove coordinates first find 0. So let's say node equals, sure, while node dot n is not equal to 0, node equals node dot x. Okay. Okay. Outputs equals this for blank and range 1,000. Node equals node dot next. Outputs append node dot n. And so let's do for blank and range. We're going to do this 3 times. Return sum of outputs. Okay, so now consider this encrypted file. All right, this is taking a lot longer than I expected it to. That's fine. Let's say numbers equals int f. Yep. And so EF equals encrypted file of numbers, ef.mix, print ef.grove. So let's run that and see what happens. 2145. That's not even possible. Try that again. 4. Okay, so that does not. Okay. Let's look. We have 2, 1, minus 3, minus 3, 2, 0, 4. And we have 1, minus 3, 2, 3, minus 2, 0, 4. Then we have 1. So minus 3. So this minus 3 is moving around. So he should go. Let's more explicit here. Where is this step? Print. To move 1, node 2 to move 2, node 3. Okay, something has gone wrong. What is this? Let's try this again. -3. Did Copilot insert that? Node -3 to move 4. And then I get 1, 2, 3, -2, 0, 3. 1, 2, -2. Okay. Short arrangement 1, 2, -3, 3, -2, 0, 4. 1, -3, 3, -2, 0, 4, 2. That's fine. 1, -3, 2, 3, -2, 0, 4. 1, 2, 3, -2. So -3 should move 1, 2, 3, 4. One, 2, 3. One, 2, 3. Let's see. -3. 1, 2, 3. Or 1, 2, 3. Because if I move 1, 2, 3, 4, 5, 6. So do I need to mod by this -1? Let's try it again. One, 2, 3, -2, -3, 0, 4. 1, 2, -2, 3, 0, 3, 4. 1, 2, -3, 0, 3, 4, -2. 1, 2, 3, -3, 0, 3, 4, 2. 4 to move 4. And then and these together produces 3. All right, so okay, I still have an extra print statement somewhere. Okay, so assert that ef.grove equals 3, ef equals encrypted file numbers, ef.mix, print ef.grove. All right, let's run this. Am I doing it too slowly? 2215. Let's try that. Ponder. First, you need to multiply each number by the decryption key before you begin. This will produce the actual list of numbers to mix. Second, you need to mix a list of numbers 10 times. Remember, numbers are mixed does not change number. So number 3, after 1 round of mixing, after 2 rounds of mixing, after okay. Assuming my mod is right, that should be okay. Multiply each number by the decryption key. Okay. So decryption key int equals 1. That will make it do the right thing. Post init node n times self.decryption key for n and self.numbers. Okay. Second, you need to mix the list of numbers 10 times. The order in which numbers are mixed does not change. The numbers. Okay. Okay. Yes, that's fine. So equals the encrypted files numbers. Mix it 10 times, and then print ef.grove, and that should be 1623 blah blah blah. So let's run it. Okay, 16. That seems right. So assert if grove is this, that's fine. Oh, the mix is what took a while. So let's say this is part 1. And let's say decryption key equal, or just call it key, that'll be easier. Okay, EF equals encrypted file numbers comma key. Let us do TQDM so I can just make sure it's running in a reasonable amount of time. For blank in tqdm.trange10 ef.mix print ef.grove. Okay. So let us run this. I don't think it'll take that long, will it? Takes about a minute. That's fine. I can wait for a minute. So this linked list way is slow, right? Because whenever I move it, I'm actually moving it that many times. Now, doing the mod is makes it not that long, but it's still like it's like a bubble sort, right? Where it's pushing it one by one to the end rather than figuring out. So probably what I what I should have done is I should have removed it, hooked it up, walked it that many times, and then not assigned it. Now that wouldn't have been that much faster, but it would have been a little bit faster. There's probably even a faster way still, but I was having a lot of trouble with the bookkeeping, trying to do it any other way than the linked lists. So I'm willing to trade some running time for making my bookkeeping easier. And like as you saw, I sort of struggled with this more than I should have. So anyway, let no one ever say that linked lists aren't sometimes useful, because in this case, the linked list was useful. It allowed me to get this to work. I don't know why this problem was hard. Obviously, this modding by n-1 is not obvious, and as you can tell, since I did it the wrong way the first time, and I had to sort of debug painfully how to get it right. But once I did that, I think the key thing was you got to mod by something, because otherwise part 2 is not going to work. And so I did that in part 1 anyway. And so getting it right made part 2 like relatively easy, and that's that. So yeah. All right, that took longer than I wanted, but it's done, and